Okay, so in this video we're looking at multiplying and dividing surds, which is actually much easier than adding and subtracting surds. We don't need to have like surds to multiply and divide. We've actually already looked at these properties of surds. If we are multiplying two surds, we can combine them together as a single surd simply by multiplying the things under the surds. If we are dividing two surds, we can combine them together as one surd simply by dividing the two things under the radical signs. So, as I said, like surds are not required for multiplication, nor are they required for division. We simply multiply any number parts and then any surd parts. So if we're doing something like 3 root 2 times negative 5 root 6, don't forget that 3 root 2 is 3 times root 2. Okay, so 3 root 2 means 3 times root 2. And negative 5 root 6 means negative 5 times root 6. Okay, so actually all we have here is four things multiplying together, and we can multiply in any order. So we regroup the multiplication, so we're multiplying the number parts separately from the surd parts. So we can think about it as 3 times negative 5, which is negative 15, and root 2 times root 6, which is root 12. Okay, so we might at this point go, okay, well our answer is negative 15 root 12. However, in this particular example, and this won't always happen, root 12 is not a simplified surd, and so we must then make sure our surd is simplified. Root 12 simplifies to 2 root 3, and so negative 15 times 2 root 3 is negative 30 root 3. Okay, so root 3 times root 15 is the same as square root of 3 times 15, which is square root of 45. We then must make sure our surd is in simplest form. Root 45 is not in simplest form because 45 is 9 times 5, and so actually this is 3 root 5 in simplest form. Question 2, 5 root 3 times 2 root 7. Now again, like the example above, we wouldn't write out these first two lines, but we're just seeing what's happening. So we've got four things multiplying together there. We can do it in any order. So I'm going to do 5 times 2, which gives me 10, and root 3 times root 7, which is going to give me root 21. Now root 21 is a surd in simplest form. Thinking about the square numbers, 4 doesn't go into 21, 9 doesn't go into 21, 16 doesn't go into 21, and 25 is bigger than 21, so it can't go into 21, and therefore no other square number can go into 21. So 10 root 21 is as simplified as that gets. Root 22 divided by root 11. Okay, so we can just do this as root 22 divided by 11. When we have multiplication or division, we can split up or put together our surds in this way. 22 divided by 11 is 2, and so that is just root 2. Root 2 is a simplified surd. Example 4, we've got 4 root 10 over 2 root 2. Again, let's just focus on the numbers and the surds. This is the same as 4 on 2 times root 10 on root 2. That's how fractions work. Okay, so we can just focus on simplifying the surd part and simplifying the number part. 4 divided by 2 is 2. Root 10 on root 2 is square root of 10 on 2. And so we have 2 root 5. Root 5 being in simplest form. Okay, and then we might be able to expand out brackets involving surds, which is just multiplication. So if we have a single term outside a bracket, we know it's going to be that times that, and that times that to expand out the brackets. So we're going to have root 6 times root 3 minus root 6 times root 5. Now I would just do those multiplications as I expanded. So root 6 times root 3 is root 18, minus root 6 times 5, that is root 30. Okay, root 18 is not in simplest form because 18 is 9 times 2. 30 square numbers, 4 doesn't go into 30 a whole number of times, nor does 9, nor does 16, nor does 25. 36 is bigger than 30. So root 30 is in simplest form. We're just going to leave that as root 30. Root 18 is root 9 times root 2, and so it is 3 root 2 take away root 30. That's as simple as we can get that. They're not like surds and they won't collect together. Okay, and example 6, again we've got a bracket to expand out. Now be careful about the fact that you've got negative 2 root 3 here when you expand. Okay, so this is going to be, that root 50 is just going to sit out the front there, but root 50 is not in simplest form, so let's simplify that. 50 is 25 times 2, I'll come back to that. Then we're going to have negative 2 root 3 times root 6, so it's minus 2 root 3 times root 6. and negative 2 root 3 times negative root 3, so it's going to be positive, so plus 2 root 3 times root 3. Okay, so let's see where we're at. Root 50 is root 25 times 2, which means it is 5 root 2 in simplest form. This second term here, multiplying the roots together, root 3 times root 6 is sorry, I've got the 2. We've got minus 2 lots of root 3 times 6, so it's root 18. And then we've got plus 2 lots of, now root 3 times root 3, that's root 3 squared. And root 3 squared is just 3. Okay, so I would never write root 9. Root 3 times root 3 is 3 because it's root 3 squared. You can write root 9 and then simplify it to 3, but again, trying to be efficient. In a lot of these examples, I'm writing out more steps than what I would usually do. Okay, so in order to illustrate to you what's happening, I'm writing out more steps than what I would usually do. If you can do it more efficiently, you don't need to write out all the steps. If, however, by skipping steps, you are getting the answers wrong, slow down and write down some more steps. Okay, until you get more accurate, then you can start to drop off the steps. Okay, so this is just 2 times 3. Alright, root 18 is not in simplest form, so we've got 5 root 2 minus, we simplified root 18 over here, root 18 turned out to be 3 root 2, so let's just go straight to that. So that's 2 times 3 root 2, and we've got 2 times 3, which is 6. So we've got 5 root 2 minus, that is 6 root 2 plus 6, and so 5 root 2 take away 6 root 2 is negative root 2 plus 6. That's perfectly fine, but it just might be a bit neater to write the answer as 6 minus root 2. They're not like terms, they cannot be collected together. The answer is 6 minus root 2. Okay, so some practice multiplying and dividing surds, including expanding out some simple brackets, making sure, as always, surds are given in simplest form at the end. So the practice is in exercise 3C.